Yes, this video we are going to solve this question of lead code to some problem. So what it says, कि array of integer nums and an integer target. Okay, we have to return the indices of those two's number such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in. Okay, so if oh, let's take some sample to understand the problem better. Okay, so if we are given a int, suppose the value 5, okay, and the target is a 8, right? So we have to return the indexes of uh, the two elements which add up to 8. Okay, so here the first thing is this: the array is unsorted. Okay, the array is unsorted. Okay, and there is no negative scenario. We will for each like test case we will have one solution. Okay, exactly one solution. So I can write for every test case exactly one solution is there. Okay, so here we have to return the array of 0, and was at 0 it is 5, and at 3 it is 3. So 5 plus 3 is 8. So we are returning the indexes of those two elements which add up to the 8 target value. Okay, so the brute force method for this solution problem is this: we can do the array from 0 to n, and inside another loop can loop it from 0 to n. Okay, and here you can check if 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 the nums of I plus nums of j equals to target, and we return int, a new int I. So this is the brute force method. The time complexity is a big O of n square. Have one loop inside another. The space complex, extra space, auxiliary space is O of 1, because we are not using any other variable for solving the problem. Okay, So other than this, we have uh, one more approach. Hmm. The second up, the second second, just a second. I was saying the second solution uh, that we can do is of sorting, right? The sort for sorting, the time complexity will be O of n log n. Okay, what we will do, we will first sort the array, arrays dot sort third, right? And now we can use the binary search up. What is that? We will have an array of nums of 4, 6, and 1. Okay. So suppose the target is 10. Okay. So we will place a pointer I here, a pointer j here. Okay. No, it's like this. We have to sort the array first. If we will sort the array, it will become 1, 3, 4, and okay. But this approach will not work here, right? If we have to return, sorry, and boolean uh, or the element itself, then we can do this with this approach. But in this case, we have to return the indexes of the elements. So why it fails? Because after sorting, the indexes, original indexes are like changed, right? Because one was there at index 3 and now it's at 1. Okay, so we have to return the indexes of original array. Okay, but we have modified the array, so here the indexes are changed. Okay, so we cannot use this approach because we are returning the indexes because of indexes. Okay, uh, the last and optimal approach is this. We will use and data structure, and the data structure will be map. We will use an map of integer and integer. Okay, let's call this as map. So new hash map. Okay, so we are having, okay, now what we will do, we will iterate the array. We will check, we'll find the complement, the target minus nums of I. We will check if map contains the complement, then we find our solution. Done. uh, have got get got complement will return the index. So else what we can do, we can just put the value in the map dot put terms of I the are good with this solution. Now I try run this code so that we is it dashes just moved above, so don't mind it. So suppose it is 2 4 8, so the meant 5 uh, target element is 5. So what we will do, we this is app is 0. What we are doing is complement is equals to target, that is 5, and minus 2 is equal to 3. Okay, so we will check if 3 is there. 3 is there in the map, but for now our map is empty, so it will not uh, go inside this if condition, and it will add the value, right? So will add the nums is 2 with the index, because why we are storing the index, the main reason is we have to return the original indexes of the elements, right? Okay, now the value of I will increment, will move here and now the I is 1. We will find the complement which is 5 minus 4, 1. As we can see, 1 is also not here. Again, we will update the map with the nums which is 4 and the index which is 1. Right now, the I will move here. The value of I is 8. I is equals to 2. We'll find the complement. The complement is target, which is 5 minus 8, is minus 3. Minus 3 is not here. So again we will register 8, and 8 is the element, 2 is the index. We'll again increment the value of I. We are here 7. Okay. I is equals to 3. We'll find the complement. So 5 minus 7. Minus 2 is not here, and negative also. So 7, and right now the I is 4. Okay. So I is equals to, we will find the complement, which is 5 minus 3 is 2. So we will find if we have 2 in the key, so we can find it is present here, right? So we will return the index. So here we are getting the index of the value. So here we will get as 0, and at the place of I will get as 4. Element 0 and 4 are the elements which sum up to 5, right? I hope you got it. The time complexity is big O of n, because we are using one loop only, and the space complexity also big O of, because we are using a map. So this is the most optimal solution. Okay, so let's just quickly write it. So we will create an map. We'll find this get target is okay, and after this we will check if have contain key complement. Okay, and what will do, dot get I, and just add the value with the index in the map, and like the return type is array, so here just return and dummy array. Will never reach up to this point, because each test case have exactly one solution. So if it will have the one solution, it will return from here. It will never reach the end. Okay, let's run the code. Just log in quickly. can code. Test cases this. That's all for this video, guys.